Hi and welcome back to Gaffy's Grinds. This is video 5 in our series on radioactivity for leaving Cert Chemistry. We have previously looked at how Henry Becquerel accidentally discovered radioactivity when his rock collection caused his photographic plates to turn black. Now, Henry concluded that the rocks must be giving off some kind of radioactivity, but this didn't really help us to figure out, well, what is actually inside the rocks that causes this to happen. Is there an element or a particular versions of an element that suffer from radioactivity, that break down and give off this radiation? So to understand that, we need to begin with a story, and the story begins with these two people. These two people, well, the woman in the picture on the left was from Poland. Her name was Marie. And in 1891, Marie moved from Poland to Paris in search of a better life and particularly of some education. She applied to attend the university in Paris, and when she applied, she got accepted, and she was assigned to do some work in a lab, which which was on the cutting edge of this new radiation field. So it was soon after Becquerel's discoveries, and this lab had been set up. And while working in the lab, she met the man in the picture, and his name was Pierre Curie. And Pierre was very passionate about science and research, and he really was getting stuck in, and he was really, really interested in this field of radiation. And working side by side for the year through their love, shared love of science and research, they worked side by side and they ended up falling in love. And within the year, Pierre had asked Marie to marry him. Now, originally, Marie turned him down, not because she didn't want to marry him, but because she did not want to stay in Paris. She wanted to return to her native Poland because I suppose that was her home. So she originally turned him down and she went to try and move back to Poland. And she applied to some colleges there where she wanted to work. And like she had just got some really good experience under her belt working in this lab in Paris. So she knew a lot of stuff and could have brought a lot of stuff to a university in Poland, but they rejected her based on the fact she was a woman. Unfortunately, in the late 1800s, uh, science and the workplace was not seen as a place for women. Thankfully, that has changed. But she left Poland disappointed and returned to Paris. But she settled into life there, and she started to work with Pierre again, and they did get married. And they spent their whole marriage working side by side, which I think is really cool that they can work together, do the thing they love together, and still spend the days together and really try and achieve something together. And they were such a good team that they actually ended up winning a Nobel Prize. Now, they shared the Nobel Prize with Henry Becquerel because they were kind of all working on the same idea. And what was the idea? Well, the idea was that they discovered or they isolated the first radioactive elements. So they discovered or they isolated the first radioactive element. So it wasn't just a rock giving out these emissions anymore. They actually discovered two elements which are radioactive, and those were radium, and the other one was polonium. Radium and polonium. Now, it was not all plain sailing, and unfortunately, Marie suffered again because of the fact she was a woman. When the original Nobel Prize was announced, it was announced only for Pierre and for Henry Becquerel. Only the men's names were attached to the Nobel Prize. And fair play to Pierre, he stood up for his wife and he said, absolutely no. He complained. He said, my wife has been as important as everybody else in these discoveries, if not more important. And if you're not going to include her name on the prize, then I do not want to be associated with it. And he really stood firm. And what happened is they did add Marie's name to the list. Now, why were they reluctant to do that? They were reluctant to do that because no woman had ever won a Nobel Prize before. So Marie became the very first person to win a Nobel Prize. Now, thankfully, there's been lots more women who have won it since, but before this, no one had ever even considered giving a Nobel Prize to a woman. So it was really important breakthrough for women in science, and thankfully, Pierre did put his foot down and say, no, this isn't right. Uh, Now, I suppose in further honor of Marie, later on, this element was actually named after her in a way, because the polo bit refers to Poland. And that, of course, is Marie's native country. Now, why didn't he just come out and name it Curium and give it a proper name after her? I'm not sure. That would probably have been even a greater honor, but nevertheless, it is named after her. It's named after her home place, Polonium. So radium and polonium, these are elements, radioactive elements discovered by Marie and Pierre Curie, radioactive elements. So that was their big discovery, but it was only one of much stuff that they did. Now, unfortunately, their life suffered some tragedies, and Pierre died quite young because basically he got hit by a horse-drawn carriage in the street, which is the equivalent nowadays of getting knocked down by a car. There wouldn't have been many cars at the time, so horse-drawn carriages, and it hit him and it killed him. He was quite young, so it was quite a tragedy. And as well as that, Marie died quite young. And the reason why Marie died quite young was because she got cancer. And the reason she got cancer is because she spent so much of her life working with radioactive elements. Unfortunately, they just really did not understand the dangers of it at the time. It was so new and nothing had been tested that they didn't realize that this was causing them quite a lot of harm. And to this day, where Marie is buried, she's buried in a tomb, a big marble, thick marble walls of a tomb in a church. And even now, the marble has to be lined with really thick layers of lead on the inside. And the reason for this is to this day, almost 100 years later, Marie's body is still so radioactive. So if people go to visit and pay their respects, if they stand at the grave, at the tomb side, and don't forget you've got big, thick marble walls, even that is not enough to stop the radioactivity from leaving her remains. That's how much of this stuff she was exposed to. That's still her remains are still radioactive this long afterwards. They had to protect or layer her tomb with a really thick layer of lead to block the radiation. So unfortunately, they just did not understand the dangers of what they were doing at the time, but nevertheless, they made great contributions to the field of radioactivity and science in general. Now, what is going on inside these elements, radium and polonium, that causes them to be radioactive? Well, what I'm about to draw is I'm about to draw a radioisotope, which is an unstable isotope. So this here is an unstable isotope. It's got protons and it's got neutrons. Okay, so protons and neutrons is large, unstable nucleus. What happens is it's got too much energy and it's got an unbalanced amount of protons and neutrons. This element is radium 226. That's the isotope. And it's got the symbol, Ra is radium. It's got an atomic number of 88 and it's got a mass number, well, it's radium 226, so it's got a mass number of 226. And what's going to happen is eventually this nucleus is going to break up and it's going to emit some radiation. And the radiation it emits is an alpha particle. Now, an alpha particle, we learned before, is made of 2 protons and 2 neutrons. Okay, so it's got a mass of 4. And it's got an atomic number, because it's got 2 protons, it's got an atomic number of 2. We give it this symbol, Greek letter alpha. Now it's the same as a nucleus of a helium atom. A helium atom would have 2 protons, 2 neutrons, and the helium nucleus would have no electrons. If I had a helium atom, it would also have 2 electrons, but an alpha particle does not have any electrons. Because of this, it has a +2 charge. Comes from an unstable nucleus. Okay, I'm going to ask you some questions now, and what I want you to do is I want you to speak your answer to the screen. Okay, so what is the mass of an alpha particle? On 3, 1, 2, 3. Okay, I hope you said the mass of an alpha particle is 4. What is an alpha particle made of? 1, 2, 3, speak your answer to the screen. Okay, so an alpha particle is made of 2 protons and 2 neutrons. What is the charge of an alpha particle? On 3, 1, 2, 3. The charge of an alpha particle is +2. It's got 2 protons, no electrons. Where does an alpha particle come from? 1, 2, 3. Okay, I hope you said an alpha particle comes from an unstable nucleus. Good. Now, I'm just going to take this and I'm going to move it up here. That's your alpha particle. Now, obviously, if our nucleus has broken up and spat out an alpha particle, then what's left behind is a different nucleus because it's just lost 2 protons and it's lost 2 neutrons. So it's not the same nucleus anymore. Okay. Now, obviously, there's a lot more protons and neutrons than this, but I'm not drawing them all because it would take too long. Okay. So that there is the new nucleus. Now, we have an equation, a way that we can work out what the new nucleus will be. We do this by writing what we call, we write an alpha decay equation. Okay, and it looks like this. We start with radium-226, and we produce the alpha particle. Alpha particle has an atomic number of 2 and a mass number of 4. Okay, let's find out what this nucleus is. So I'm going to make a few boxes that we can fill in with the information. So we have 2 numbers and a symbol to find. The first thing we need to do is find out what has happened to the mass. The mass was in the beginning, it was 226. It's losing an alpha particle. That means it's losing 4 of its mass. So I'm going to subtract 4 from the mass, and that gives me 222. So the new particle will have a mass of 222. What about the atomic number? Well, the atomic number was 88. And I am taking away 2 because there's 2 protons in the alpha particle that's been lost. So the new atomic number is 86. So my numbers here are 86 and 222. So I'm going to go to the periodic table and I need to find the element that has an atomic number of 86. So over here on my periodic table, there I see it, 86 is Rn, or radon. So my new element is radon, or N. So very interestingly, I have changed the element. I never do this in a chemical reaction. When I put things together normally and they do a chemical reaction, it's still the same element, still the same stuff at the end. We just move electrons around. But this time, the nucleus is actually changing. This is a nuclear reaction. It's different, okay? So this is an alpha decay equation. Let's do another one. So say we have another radioactive isotope, and we may as well do the other one that Pierre and Marie discovered. We already did the first one, radium. So the second one, what was the name of the second element they discovered? On 3, speak your answer to the screen. 1, 2, 3. Okay, I hope that you said polonium. Okay, so there is an unstable isotope and its symbol is PO. This is polonium. And the isotope which is unstable is polonium-210, which has a mass of 210, and polonium's atomic number is 84. Okay, we can see what happens when we do an alpha decay by writing an alpha decay equation. So we know we're producing an alpha particle. Alpha particles have an atomic number of 2 and a mass number of 4. So the next thing we need to do is work out, well, what is the new element formed and what is the atomic number and mass number? So we do this by finding, first thing I want you to do is find out how much does the mass change by. So pause the video and find out how much has the mass changed by. Do that now, please. Okay, I hope that you did. 210, because that was the original mass. Take away the mass of the alpha particle, which is 4, equals 206. That's the new mass. Now I want you to do the same thing. Find out how much has the atomic number changed by. What's the new atomic number? Pause the video and do it. Okay, so you should only be playing if you've found a new atomic number. It's 84. Take away 2 gives me 82. So I need to find the element with atomic number 82. That's going to be over here on the periodic table. There's 82. Element number 82 is Pb. Pb is lead. So I have found that my new element is lead, Pb, and its mass was 206. 206. It really is that simple. Okay, hopefully you guys are going to be able to take over now in a second. Okay, so what I'm going to do is we're going to practice a couple now. Say we start with this americium, Am, and its mass is 241. That's a radioactive isotope. Its atomic number is 95. Obviously, we're going to get an alpha decay, which is 2, 4, plus I want you to find out what is the new element and what are the numbers. Pause the video and do that now. Okay, so you should only be playing if you filled in the boxes here. You should have written the whole thing out and filled in the boxes. If you haven't done that, pause it and do it properly. Okay, so hopefully you saw what we would do here is to get the mass, we'll do 241, take away 4, gives you 237. And then we do 95, take away 2, gives you 93. So I've got 237 is the mass, and I've got 93 is the atomic number. The new element is capital NP. Okay, time to do another one. Try this one. Uranium. We've got uranium 92 is the atomic number, and the radioactive isotope is 238. Pause the video and write the alpha decay equation for that, please. Okay, what you should have had is alpha, which is 4 and 2, plus the new element is 234 is the mass, 90 is the atomic number, and the element is thorium. Okay, I'm going to practice another one now. We've got, try this one, thorium 238 90. So pause the video, practice that one now, please. Okay, so what you should have had is an alpha particle, 2, 4, plus the new element is going to be radium, or A, 224, and the atomic number is 88. Last one, this one's going to be a little bit harder. We're going to start with the products. I'm going to say we have an alpha particle, A, alpha 2 and 4, and the new nucleus, or the new element at the end, is radon 222 and 86. What I want to know is what was the isotope that we started with? What did we start with? So pause the video and see if you can figure that one out. Okay. All right. Well, hopefully you figured out that if you want to find out what you started with, you would have to work backwards. So here we would have to we'd have to add the alpha particle back in. So we'd have to do 222 plus 4. We're adding back in the mass. And we'd have to do 86 plus 2, add back in the 2 protons. You're going to get 226 for the mass and 88 for the atomic number. And that's going to give you radium. Well done if you said radium. Good job. That was a little bit trickier. Radium 88. And the mass is 226 that you worked out over here. All right, well done. If you managed to do them, good job. You're ready to do some more practice. All right, so I've got some fill in the blanks for you. So what I want you to do is I want you to pause the video and I want you to write the paragraph out and fill in all the keywords. Pause the video and do that now. All right, a reminder that you should only be watching if you have paused the video, written out the whole paragraph, not just the blanks. It's good practice for your scientific writing, and you filled in the blanks with what you think are the missing keywords. Here are the answers. So pause the video, make your corrections. Well done. If you got those right, excellent. Next one. Got a couple more questions for you to do. Just 3 short questions. Pause the video, do that now. Okay, so you'll only be watching if you have done these 3 questions. How many protons, neutrons, and electrons does an alpha particle have? So an alpha particle has 2 protons, 2 neutrons, and 0 electrons. Well done. If you got that right, good job. Who extracted the first radioactive isotopes? That would be Pierre and Marie Curie. Curie. Pierre Marie Curie. How did polonium get its name? It's named after Marie Curie's country of birth, I suppose. Country of birth, or named after the country she was born in. If you just said it's named after Poland, then I get where you're coming from, but that doesn't really explain why it's named after Poland. It doesn't explain how. That just said it's named after Poland. Well, what's special about Poland? Why does Ireland not have an element named after it? Irelandium? Why is there no such thing as that? Well, the reason why it's named after Poland is because Marie Curie discovered it and she was from Poland. So you need to be a little bit more specific than just say it's named after Poland. All right, that's it for alpha decay. You should now be able to write equations for alpha decays, and hopefully you got enough practice today. You should also know about Marie and Pierre Curie's contributions to radioactivity. You know that they discovered the elements radium and polonium, and these were the first radioactive elements to be identified and isolated. So I hope you enjoyed the video. I'll see you in the next one.